We need to form the partial differential equation by eliminating constants a and w from z equal to a e the power wt sine wx. So we need to eliminate these two constants to form the partial differential equations. So let's start with the solution. So this is the equation given to us and we need to form the partial differential equation from this. Let me mark this as 1 and we have to first differentiate 1 with respect to x. So we get partial derivative of z with respect to x equal to a into the first function into the derivative of second, that is the cos of wx into w, plus the second function into the derivative of first, that is 0. I have taken this to be the first function, this to be the second function, right? Okay. So partial derivative of z with respect to x is equal to a into w into e the power wt into cos of wx. Similarly, we need to differentiate the equation 1 with respect to t now. Why t? Because z is depending upon two variables, x and t, right? Z is the function of two variables. So now differentiating 1 with respect to t, we have partial derivative of z with respect to t to be equal to, okay, let me mark this as 2. So this is a into first function into the derivative of second function, that is sine wx. So differentiating this with respect to t gives 0 plus the second function into the derivative of the first one. So e the power wt into w. We have to derivate this with respect to t. So we are getting partial derivative of z with respect to t to be equal to aw into e the power wt sine of wx, and marking this as 3. Now if you notice that I'm having in equation 3 aw e the power wt to be the same as in equation 2. Only I'm having the difference of cos wx and sine wx. I need this to be the same so that I can eliminate a and w both. What to do now? If I differentiate again 2 and 3 with respect to x and t respectively, then I get the right hand side to be the same. Let's do that. I'm having partial derivative of z with respect to x to be equal to aw e the power wt into cos of wx from 2, right? And from 3, I'm having partial derivative of z with respect to t to be equal to aw e the power wt sine of wx. If I derivate this again with respect to x, so we get aw e the power wt, because we need to derivate with respect to x. So these are constants. So this is minus sine of wx into w, right? Or we can also write this as minus aw square into sine of wx, right? Similarly, if I differentiate this again with respect to t, I will be getting, because I need to differentiate with respect to t, so these two are constants. So aw sine of wx, and differentiating with respect to t, this we get e the power wt into w. So we can write this as, so multiplying this w with this gives w square. And let me write e the power wt first, and then sine of wx. So marking this as 4 and 5. So from 4 and 5, we have the right hand side to be the same but with different signs, right? If I add 4 and 5, these two equations, I will be getting the right hand side to be 0. That means a and w are now eliminated from the equations. So on adding 4 and 5, we get partial derivative of z with respect to x of second order plus partial derivative of z with respect to t of second order is equal to, these two cancelled out when I add these two. So here we get 0. So this is the required partial differential equation of order 2, right? So this is the required partial differential equation of second order. Alright, thank you. Stay blessed.